Hi guys, Dr. Diaz again. We should notice this in respect to this integral, and is that it says here that the power would not work if r is equal to -1. What would be that? Okay, let's look at this example. Let me do if I do something like this. Let's try that one. Suppose we had actually x to the -1 dx, which is the same as the integral of 1 over x dx, right? But if you have it in this form, which is the one that I want to solve, x to the -1 dx, and we use this rule, you will have x to the -1 plus 1 divided by -1 plus 1 plus c, and what happens? You will get what? X to the 0 divided by 0 plus c. This is the reason why or r, the exponent in this fellow, cannot be equal to -1, because then you will have division by 0 is undefined. Now I can tell you something now. Integral of 1 over x dx is, here it goes, natural log plus c. Aha! We haven't seen this one yet, and the way you solve this is by using integration by parts. Yeah, it's a very difficult integral to solve. It looks innocent and small, but actually very difficult. I'm giving you here a heads up. And actually, something you have to put is in absolute value to make sure that we only use in positive values, since we know that negative numbers do not have logarithms. But for now, I forget to mention why they say any power except for r equal to -1 is because you will have something like this, division by 0, and division by 0 is undefined. Something like this, division by 0, and division by 0 is undefined. So let's go to the next problem. Oh, look at this one. X to the 17. So I'm guessing everybody knows it's going to be 17 plus 1 divided by 17 plus 1, which is x to the 18 plus x to the 18 divided by 18 plus c. Yeah, right? Cool. Now let's look at another problem. 1 over x cubed. 1 over x cubed. Well, this is the same as x to the -3 dx. And, well, it's not -1, so it must work. Yeah. It should be what? X to the -3 plus 1 divided by -3 plus 1 plus c. So this is going to be what? X to the -2 divided by -2 plus c, which is the same as, put the minus sign here, 1 over 2x squared plus c. Oh, let's see if that is true. There it is. -1/2 x to the -1/2. This is the same. This is the same as writing -1 over 2x squared plus c. These are actually equivalent. So we get it right. I mean, something you write the expression like this, something you don't. Let's see another example. Oh, look at this. April 1st, because today is March 31st. Happy birthday. Okay, look at this one. X square root of x, which is the same as writing as the integral of x to the 1/2 dx. Okay, so if we use the property, this is the same as x to the 1/2 plus 1 divided by 1/2 plus 1 plus c. And we know that 1/2 plus 1 is the same as 1/2 plus 2 divided by 2, because 2 divided by 2 is 1. We have common denominator. This is going to be what? 3/2. So this one is going to be here. This exponent here is going to be x to the 3/2 divided by 3/2 plus c. The 3/2 turn out to be what? 2x to the 3/2 divided by 3 plus c. Yeah, because 2 divided by 2 is a reciprocal. The 2 goes up, and then you have 2/3 x to the 3/2 plus c. And if you want to see the answer here, the way they did, there it is. Bunch of mumbo jumbo there. And the next slide. Look at this next one. Oh, some integration rules. Well, first of all, the first one, which is telling us that this fellow here cannot be -1, because otherwise it will not work. Then we have the integral sign is negative cosine plus c. The integral of cosine is sine plus c. The integral second is tangent, or second of x dx is tangent of x plus c, and the integral of cosecant square is x dx is going to be minus cotangent x plus c. The integral of secant x tangent x dx is equal to secant plus c, secant x plus c, and the integral of cosecant x cotangent x dx is equal to minus cosecant x plus c. Now you all know these. If you find the derivative of sine, the derivative of cosine, it's going to be minus sine, but because it has a minus, minus minus is going to be plus sine here, so we got back the integral. The derivative of sine is just cosine. The derivative of tangent is secant square. The derivative of cotangent, it will be minus cosecant square, but because there's a minus sign, minus minus is going to be plus. And so on and so forth. So we know how to do this derivative. These are really important. You should have them handy, or in that formula sheet that I gave you a long ago, or you can download it from the web page, from Canvas. Now look at this one. These other rules or theorems of antiderivatives of integration. Suppose we have two functions, and they have an antiderivative, and they have a constant. Well, if you have a constant, you can take the constant out of the integral, and you just do the integral f of x. And something else, if you have an expression, a function, you can do even much easier. You can take not only the constant out, you can divide this into two different integrals. That's what it's saying here. It's basically to save you time and do the problem much easier. And so this one is an expression both by dx. You can divide this into two integrals. One that it says 3 cosine of x dx, plus the other one that says integral of 4x to the 8 dx. Now this one here, you can take the 3 outside. It's going to be 3 integral of cosine of x dx, plus here you can take the 4 out, 4 x to the 8 dx. What's the integral of cosine? By definition it's going to be sine, so let's keep going. Equal. This is going to be what? 3 sine of x, and now we get rid of the dx because we're doing an integral, plus 4, and this one is going to be what? X to the 9 divided by 9, right, by using the root, plus c. Now we have the constant of integration, which in the c is actually part of these two, and at the end the answer is going to be 3 sine of x plus 4 of 9 x to the 9 plus c. And that is the integral of this expression here. The example I was planning to say, which is much simpler, if I give the example that I want you guys to see, suppose I have an integral like this: 2x cubed plus 4x squared plus 3x plus 2. What's the integral of this polynomial? Actually, if you remember the way we used to do derivations, this is different from this one. Well, you know, the first one, you can do here 4 different integrals. It will be the first one, which you take the constant outside, and this will have x cubed dx, plus the second one, you would take also the constant outside, and that's going to be what? X squared dx. The third one, you would take the constant, which is 3 outside, and it will be what? X dx. And the last one, you would take 2 outside, and it's going to be integral dx. Like there was a constant here. What's the integral of this fellow? Well, we know this one is going to be 2 times x to the 4 divided by 4, right? Plus 4 times this one, which is going to be x cubed divided by 3, plus this one, which is going to be 3 times x squared divided by 2, plus this one, which is a constant, and the integration of dx is going to be just x, because the derivative of x is 1, or 2x, the derivative of x is going to be 2, and then you add here the constant of integration plus c. So this one is going to be 2 divided by 2, it's going to be x to the 4th divided by 2, plus this one is going to be, let's put here 4x cubed divided by 3, plus 3 halves x squared plus 2x plus c. Yeah, simple problem. Yeah. Okay, so let's see the next one. Yeah, here's the answer for the problem we did a moment ago.